Welcome to Skills and Academic Tuition Center. In this video, we are going to look at the parallel circuit. So while we look at the parallel circuit, we'll look at how you can calculate the electric current and as well as the potential difference in a parallel circuit, and at the same time, how you can determine the effective resistance in a parallel circuit, and also, and more importantly, the rules that govern the parallel circuit. So in parallel circuit, the current flow is branched. The current flow is branched. It is different from the series circuit, because in a series circuit, current flow is in a single path. But for this one, the current flow is branched. For example, if we have a current flowing through this circuit, we take it that we have 5 amps that is flowing. So as the current is flowing, some of the current will flow through this resistor, some of the current will flow through this other resistor. But the division of the current that is flowing will depend on the amount of the resistor. So the higher the resistance, the lower the current that is flowing. So in such a case, for instance, if we take it that this one has got a higher resistor, then this one has got a low resistance. So if this one has got a higher resistance, then it means from there we are going to have maybe 2 amps flowing through this resistance. Then this other one will have a low resistance where we are going to have 3 amps flowing. So current is going to be divided. So as it flows, we are going to have 3 amps here. Then we also have 3 amps there. We'll have 2 amps there. But once it meets at this junction, we are going to have 5 amps. So the current through the branches add up to equal the current that is flowing in the main circuit. So the current flowing through the branches add up to equal the current in the main circuit. So in this case, the 5 amps will continue to flow in such a manner. But once it reaches this junction, some of the current goes there, the other current goes there, depending on the amount of the resistance of the particular resistor. Another rule here is that each resistor in a parallel circuit has equal potential difference across it. Another rule here is that the sum of the resistors is equal to the combined resistance. So we have 2 resistors here, resistor 1 and resistor 2. So if we want to get the sum of these 2 resistors, we are going to say the reciprocal of the total resistance is equal to the reciprocal of resistor 1 plus the reciprocal of resistor 2. You can either use this one to calculate the effective resistance in the circuit, or you can use total resistance or effective resistance is equal to R1 plus R2 divided by R1 multiplied by R2. If you want, you can also use this one. Okay, so we look at this circuit where we have 6 volts supply which is connected to 2 resistors which are in parallel. So we have this one is going to be our resistor 1, then this one will be our resistor 2. So these, they are connected in parallel, they are parallel to each other. So the first question is determine the effective resistance. We determine the effective resistance between points A and B. So we have our point A there, then we have our point B there. So we are being told to calculate the total resistance. So how do we get the total resistance? So say the reciprocal of the total resistance over, we have resistor 1, then we also have resistor 2. So from here we'll say 1 over the effective resistance is equal to 1 divided by, so our resistor 1 we're going to substitute with 4 ohms. 4 ohms there. Then our resistor 2 will substitute with 12 ohms. Then from here 1 over 4 plus 1 over 12. So we have our total resistance. So here we can get the common denominator, which is 12. Then from here we say 4 into 12, which is 3. 3 times 1, you have 3. Then 12 into 12, which is 1. 1 times 1, which is 1 there. So here we are going to have 4 divided by 12. So now when you cancel out 4 there, 1, 4 there, 3. So it means we have 1 over 3. So when you have that, we're going to say 1 divided by combined resistance, which is equal to 1 over 3. So here, what we are calculating the combined resistance. We are not calculating the reciprocal of the combined resistance. So we are going to cross multiply. So when you cross multiply, you are going to have RT is equal to 3 ohms. You are going to have 3 ohms. So 3 ohms here is our combined resistance. So in a parallel circuit, the total resistance in a parallel circuit provides a low resistance. It provides a lower resistance as compared to the individual resistance of the resistors. So this is our total resistance. Okay, so we look at this other one, which is saying calculate the value of the current in the circuit. Now that we've calculated the total resistance in the circuit, and we have the voltage or the potential difference in the circuit, we want to calculate the current in the circuit. So we write our data. So our data, we have current, voltage, and resistance. So the current that is being calculated, the voltage, we have the 6 volts, which is this one. Then the resistance, the 3 ohms, that was calculated. So that one has been calculated. So now what we have to do here is to calculate the current. So we are saying current is equal to voltage over resistance. So our voltage, which is 6 volts, then divided by the resistance, divide there, you're going to have 2 amps. So the 2 amps, that is the current which is flowing in the circuit. Thank you for watching. Value for education, our pride.